Okay, here we go. Next unit. This is where we really get into algebra. I can't wait. But first I need to start off with a skill that isn't too important for 6th grade, but it is a skill you need to know. And when we get to the next lesson, which is the order of operations, you're going to be practicing exponents a lot. So we're going to spend a little bit of time in this relatively short lesson to get to know exponents, what they mean, and how to use them a little bit. When we start getting into the later grades, we'll start seeing a lot more exponents, and we'll start using them to solve much more complex problems. But for now, let's get an introduction. You know that multiplication is repeated addition, right? Like if I wanted to write 2 plus 2 plus 2, I can just write that as 2 times 3, because I wrote the 2 3 times. With exponents, this is basically repeated multiplication, okay? For instance, let's say that I had some starting quantity, like 2, and I wanted to double it. So I multiply it by 2, and that gives me 4, right? Let's say I wanted to double that quantity. So this quantity, I actually want to double that. So I would multiply by 2 again. And then for some reason, something comes up and I actually need to double this whole thing again. So I'm going to multiply it also by 2. If I read this left to right, I get 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 2 times 2 times 2 times 2 is 16. Now mathematicians, we're, how do you say it? We're kind of known for not wanting to do more work than we have to. So if we have to write out a huge string of 2's, that's going to take a little bit of time. It's going to take too much paper. So we have a way to shorten this, okay? We take the number of 2's that are being represented in our sentence here, and we use an exponent to show this. Instead of this big old long thing, we simply write 2 to the 1, 2, 3, 4th power. That little guy up there is called an exponent. The exponent tells us how many times the number 2, the base, is represented in this multiplication problem, okay? That's not too hard, right? So basically, every time we see a base represented here, we're going to show that as an exponent, okay? Now, I did mention that this is called a base. That's a good thing to know, because when we get into higher maths, and especially into algebra, we're going to be referring to this as the base. That's going to be an important word to know. So whenever you see a power written like this, an exponent, make sure you know that the big number, the main number, is called the base. And it's pretty easy to see that this little guy up here is called the exponent, or often also called the power. In fact, if you were to think technically about it, this whole thing, 2 to the 4th power, is the exponent. And the exponent is actually broken into 2 pieces, the base and the power. But let's not get too much into technicalities yet, okay? For now, we just need to know how to recognize these guys and how to write them out. Now, these 2 mean the same thing, but they have different names. And it kind of makes sense this way. This whole thing right here is what we call expanded form. I'm going to write that. And so should you. That's a very good thing to have in your journal. This is called expanded form because it's expanded out. This is the long way of writing this, okay? This little guy, all squished together and showing how many times 2 is represented in that multiplication problem, is called exponential. It's basically that word with an IAL at the end, exponential form. Which means that we've squeezed it all together into an exponent. That's exponential form. If we were to take an exponent and stretch it out so that it shows all the different bases, the number of bases that we have in that power, then we have expanded it into expanded form. Okay? So now that we've seen an introduction to this and we know the names of these guys, we're going to try a couple of these before we actually get into the exercises. If you need a little bit more time to write these down, press pause now, finish it up, and then unpause it and join me. Okay, let's try. I'm going to give you an exponential form this time, and you, or we, will write it in expanded form. Okay, let's say we have 4 to the 7th power. Okay, which one is the base? That's the main number, right? So 4 is the base. That's the one that we're going to be rewriting over and over. And how many times are we going to be rewriting it? That's what this guy tells us. Do you remember what that's called? You can call it the exponent or the power. Power is probably a little more correct because it's 4 to the 7th power. Okay? So, since the base is what's being repeated here, that's what we're going to multiply over and over and over again. That 7 tells us how many times 4 is going to be represented. So I have to write 4 7 times. 1, 2, 3, 4, 5, 6, 7. So there's 7 4s. Now remember, an exponent shows us repeated multiplication. So in between each one of those 4s, we're going to show that multiplication is happening with our little multiplication dot. You could also write those with parentheses stuck to each other, but for now, this is okay. This works. Okay? That's not too bad, right? Let's try something a little different. What if I didn't have a number? What if instead I had a variable? What if I had a y? And this is going to be a little weird, but just hang with me now because the rules are all the same. What if I had a y that I multiplied by another y, and then I multiplied it by another y, and I did that up to the point where there are 6 y's? It's hard to come up with a reason why I would need 6 y's multiplied by each other, but it does exist, and we might even get to it in later courses. But the rules are the same. Y is what's being repeatedly multiplied, so y is which one, the base or the exponent? It's being represented by the base. Okay? So what's the exponent? What power is y being raised to in this situation? Well, let's just count the y's. 1, 2, 3, 4, 5, 6. Y to the 6th power. Well, because there's 6 of them. Get it? I'm not very good at jokes. Y to the 6th power because, never mind. Anyway, there are 6 y's being represented in this string, so my exponent is y to the 6th power. Okay? Again, which form is this? It's stretched out, right? So this is the expanded form. And once I squish it all together and show how many y's are being represented with a power, this is called, check your notes, exponential form. Okay? Now the nice thing is, your exercises are basically only going to go that far. I'm going to give you several examples of exponential forms that I want you to show in expanded form. And then in the next section, I'm going to give you lots of expanded forms that I want you to show me in exponential form. Okay? One last thing, because I do have some problem solving in the exercises as well. So let me come up with an example here. The mountains right outside my house, I'm in New Mexico, so I have these gorgeous mountains called the Organ Mountains. You should Google them, O-R-G-A-N, kind of like your organs, Organ Mountains. Actually, they're named after organ pipes. They're right outside, like 10 miles away from me. And they are, let's see, how do I want to show this? They are about 10 to the 4th power feet tall. Roughly, okay? And that's from sea level. So my question is, how tall in an actual number are my mountains above sea level? Okay, well, let's first look at what we've got here. We have a base of 10, okay? And it's being raised to the 4th power. 10 is the base, this is the power. That means I can write this in expanded form. I'm going to represent 10 4 times. That's what the power is telling me to do. And that's going to tell me what to do. I'm going to multiply this 10 4 times. Well, actually, I'm going to start with 10 and multiply it 10 more times. So, what's the answer? Well, the nice thing about tens is that you basically just add zeros. But if you need to, if the numbers start getting really big when you're dealing with exponential problems, go ahead and pull out your calculator for now, okay? Let's start with 10 times 10. What is that? That's 100, right? So then I've got 100 times 10 times 10. Notice I just brought this down here and then dropped down the ones I haven't touched yet. Now I have 100 times 10. Anything times 10 means add a 0. So if I put these two together, that just means add a 0 to 100. And then the last step is add a 0 to 1,000, which is 10,000. Okay? Now again, I said roughly. I think those mountains are actually about 9,600 feet or something like that. But they're roughly 10,000 feet above sea level. Okay? So, that gives me an answer there. All I did when they gave me exponential form was expand it and then do the multiplication. Okay? You can do that anytime. And like I said, some of these numbers might get kind of crazy. For instance, 2 is a very small number. Let's try 4. I mean, 2 is a small number, but if you string them all out, it can get big really fast. Let's try 4 though. 4 to the 4th power. Now before we move too much further, how automatic was it for you? How much did you really want to do 4 times 4? That's a very common mistake. I see lots and lots of students who see exponents for the first time just think, oh, well, this is 4 times 4, that's 16. But remember, this is not multiplication here. This is repeated multiplication, okay? So that means I'm not multiplying 4 times 4, I'm multiplying 4 times 4 times 4 times 4, okay? So be careful with that. It's very easy to fall into that trap. Okay, so one more time. This is not multiplication, this is repeated multiplication. I'm representing the base 4 times because that's what the power told me to do, and put a multiplication sign in between each one. Okay? This is going to get big. Can you see that? What's 4 times 4? That's 16, right? So I'll bring these two down and then multiply by 4 and by 4 again. Now what's 16 times 4? 64. See, it's going to get a lot bigger than just 16, right? So bring down the 4 I haven't used yet. And then what's 64 times 4? Got that in your head? If not, work it off to the side. This isn't a number that's big enough to have to use a calculator, so we won't. That's 16, carry the 1, 24, 25. See that? Do you see how quickly this number grew from 4 to 256? Okay? When we get into the next course in 7th grade and even more in 8th grade, we're going to talk about something called exponential growth. Okay? Exponential growth basically means that the more you go out this way, the faster things grow. Okay? If I were to just multiply 4 times 4, that's 16. But and that just means repeated addition. Things grow in what's called a geometric way. But when you put this in exponential form and you multiply it, it's called exponential. When you're adding, basically things go up in a straight line. When you're putting it into exponential form, it might start off kind of slow, 16, but then it just takes off, okay? Again, we'll talk more about that in 7th and 8th grade because we're actually going to start graphing some of those things later on. But for now, this should be a good enough introduction to get you familiar with exponents and also be able to use them when we get into the order of operations in the next lesson. But first, open up the exercises, get some practice done. Meet me in the next video and we'll go over those relatively few exercises. All right?